So last time we talked about how the valence electrons in an atom determine the chemical properties of elements. So we will try to explain why is that so in terms of this phenomenon called screening. So take for example a sodium element. The element sodium. So the atomic number of sodium is 11 and its electronic configuration is given by 1s2, 2s2, 2 4p, 6 and 3 S1. So when we say valence electron, it is the electron that is located at the outermost shell. So for this case, the valence electron of sodium will be located at energy level N equals 3, L equals 0, and there 1 electron in that quantum state. So let's try to get a picture of what is happening. So Z equals 11 tells us that there are 11 protons, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I think neutrons too, 11 neutrons, 3, 4, 5, 6, 7, 8, 9, 10, 11. And there will be also 11 electrons. So we will have 11 electrons that will be distributed in 1s1, 2s2, and 2p6. So what does screening have anything to do with valence electrons? So these 10 electrons from 1s, 2s, and 2p will fill the S and P orbitals. So in our picture on the central field approximation, you can think of it as these 10 electrons having a charge of minus 10e will actually screen it will screen the charge of the nucleus. So this is screening. Technically, this is screening. So what is the charge of the nucleus? So the nucleus has a charge of positive 11e. So since we have 10 electrons screening the nuclear charge 11e, the remaining 1 electron here will feel sort of that it is experiencing a net charge of 11e plus negative 10e. So it's as if this valence electron, quote unquote, this valence electron feels as if there is just one electron that is sorry, not one electron. Let me rephrase. This valence electron will feel as if there is a nucleus of a charge 1e. Now, if you would try to look into a periodic table, if you have a periodic table with you, so if you don't have a periodic table, that's okay. Just look. Okay, so here we have hydrogen. The next we have in this column we have, what's this? Lithium. And then next is sodium. And let's stop at sodium. So this is called the, what's this called again? The Alkali Metals. So this group is called Alkali Metals. So they are grouped in this way because they all have one valence electron, just like this sodium atom. So they have all one valence electron. So if you would try to relate hydrogen, lithium, and sodium, they also feel as if there's only a nucleus of a charge 1e. So for hydrogen, this is its nucleus. First, just one proton, so this is just 1e and one electron. So its valence electron feels just as if it's just 1e. For lithium, it has three protons, say 3 neutrons too, and to distribute the 3 electrons in lithium, 2 electrons will fill the s orbital, and this will have a charge of minus 2e, while the charge of the nucleus is positive 3e. So it's as if its net charge is 3e plus minus 2e. This should also have the same nuclear charge of, so take note, this is not the actual nuclear charge, but this is like the screened nuclear charge of 1e. So the remaining electron here, 1 electron, will experience a screened nuclear charge of 1e. So all the other elements here in the alkali metals group will have the property of one valence electron that is experiencing a screened nuclear charge of 1e. That is why they have the same chemical properties even though they have different atomic numbers.